By guessing, I could just list things like, oh, head and 4, a tail and 3, a tail and a 1. What else could happen? It's not the most organised way of approaching it. So what we're going to do is we're going to improve our organisation. And we can improve our organisation by using a two-way table. Actually, I made a couple of spare ones down here. Copy them. Now it doesn't matter which way round you use these. As long as you're being consistent, let's copy them both. Let's move that one up. As long as you're consistent with what you're doing, either way round, the sample space diagram works and helps us organise our information. So we're going to organise our information. Across the top, well, this is short, so I'm going to do coin. And as you've all said, we can actually do, a coin can come out with head or tail. And down the side, we've got our spinner. And the spinner can score 1, 2, 3, 4, or 5. Or on the other diagram, we could do spinner. 1, 2, 3, 4, 5. And we can do coin, head or tail. And that means that we can look at the situation and list everything just by the two things that give the headings at the top and at the side. So the first one is head 1, tail 1. Head 1, tail 1. And you can keep going through. Okay, so we could actually do those things right through. Now, from that outcomes, we can now start making lists of probabilities. So I could calculate the probability of a 1. How many 1s are there in the diagram? I'm just going to use the right-hand diagram, but notice I can still do it on the left-hand diagram as well. So how many ways can I get a 1? Those two. So my probability of getting a 1 is 2 ways out of how many outcomes are there. So the number of ways of getting a 1. And this is the number of all. Number of different things that can happen is only the numbers in the pairs we've written. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 possibilities, 10 outcomes. So that means the probability of a 1 is 2 over 10, or you can simplify down to 1/10. But remember, to 1/5, sorry. Remember, you only have to do that when it says simplify. I'm guessing in the worksheet they might have simplified their answers again. But remember, I'm at OK if you don't simplify your answers unless the question says so. So we could also say, what's the probability from the diagram of a 2 or a 3? 2 or a 3. Are those 4 out of 10? So we've got 4 out of 10. And I can simplify it to being 2/5. Only if you have been told to. Okay? But there is an oddity. What's the probability? Let's first of all look at the probability of a head and 4. That's just that box, and that's 1 out of 10. What if I asked the question, what about a head or a 4? So if I was thinking about all the heads, what I can do is I can highlight all the heads. Where's my pen gone? It's there. All the heads, the top line. And I want 4s It doesn't matter if it was a head or a 4. So we've got that one. Now, if you have a look at that question, we've got a problem. And the problem is, now we're going to double count. There's a risk we will double count the H4. You need to be careful that you don't double count. Yeah? So type into the box, how many ways do you think that we can actually get a head or a 4? So yeah, we've only got 6 numbers in here. We're only counting that 1, 2, 3, 4, 5, 6. We don't normally count things again, so we've only got 6 things out of 10. There are 7 elements we could tick off, but we double count this one, this H4. So this one would simplify off to 3/10. Only 3/5 again. I keep saying tenths. My fault. So I'm just going to get you started for a couple of the questions that are coming up. They often will ask you to do a diagram for 2 dice. So let's label the sides up. I'm going to label them using blue, but this one is red. What numbers can come out of the red dice? Blue. Yeah, it's not 1 over 6, but the numbers that come out are 1, 2, 3, 4, 5, and 6. And on the blue dice, 1, 2, 3, 4, 5, and 6. Now, depending on the question, you might need to use a few of these again. Margarita, I don't know what B1 mean. You don't need to list the colour, because each one has a different number. Yeah? What I could do, if I had time, I would go back and colour all of these so that they're red things are red, blue things are blue. But what we've got is we've got 2 lists of numbers that can be combined. Now, things they might ask you to do with these numbers are things like total or sum of 2 numbers of the dice. What you'd normally do if you were playing Monopoly. So we could do the total. They could say, what's the difference? So then you do the subtraction, but difference, ignore the sign. So the difference between 2 and 1 and the difference between 1 and 2 are the same. They would actually be both 1. They may say product. And that means multiply them. Or they may just look for combinations and say things like where red is greater than blue. Now, each of these could wind up with you having a separate diagram to solve the problem. When I do these, I often say what I'm doing in the diagram in the top corner. So this box in the top corner here, let's go for the difference. So the difference between 1 and 1, nothing. Difference between 1 and 2, 1. 1 and 3, 2. Difference between 1 and 4 is 3, 4, 5. And keep going. So difference between 2 and 1, ignore the sign. It's still 1. Difference between 2 and 2, nothing. 2 and 3, 1. 2 and 4, 2. 2 and 5, 3. Difference between 2 and 6 is 4. It doesn't matter which way round you do the subtraction, you just want a positive number answer. Okay? So coming down. So what they might ask us to do with these is say what the probability is. Now, before we start, Can you work out how many outcomes are there? How many things could happen all together? Everyone have a go, put it into the chat. Now the number of outcomes is the 36. We're only counting inside Sabia. We only count the numbers inside the grid because this is the combination of two things happening. This number down the outside is only one thing happening, so it doesn't count. And a short way to find it is, well, we've got a grid, which is a rectangle, which is 6 by 6. Above, we had rectangles that were 2 by 5, the 10. So the number of outcomes was 10. So now we know the number of outcomes, all our probabilities can be written in that way. So we could ask the question, what's the probability of scoring 0? N is how many zeros are there. How many zeros are there in my answer grid? 6, yep. P0 means probability. So we've got 6. Sorry, I'm just finishing writing the word notes on there. So we have 6. How many things could have happened altogether? Our number of outcomes, 36. So my probability of getting a 0 in this game, where I subtract 2 dice, is 6 out of 36, which would simplify down to 1 over 6 if you were asked to. And that means that if I had 360 games, I would expect to get 0 60 times. That's what we can read this as. So this means from 360 games, we expect 60, 0. 720 games, I'd expect 120 zeros. So this proportion describes how many of that answer would I expect to see. We could ask the question, probability of a 2. So the probability of 2s. How many 2s are there? 1, 2, 3, 4. 1, 2, 3, 4. So that's 8 out of 36. Both of those will share by 2. So I'll put the 2s in. So divide both by 4 to give me 2 over 9. 2/9. Okay. I'm lagging, am I? If anybody else is having problems, can you let me know? I'm trying to just video it as well at the moment, which might interrupt the computer internet connection. Do one more. What's the probability of scoring 6? How many 6s are there inside the sample space diagram? Okay. Yeah, Sabia, good. None of them. There are no 6s inside the diagram, so my probability is 0. That's how you can use a sample space diagram to write probabilities. Depending on the situations, you might be asked how many ways are there to get the same number? How many ways are there to get different ones? For each of this situation, draw a new sample space diagram. Now, I've given you a hint sheet for the exercise I've set you. They're the starts for the sample space need. Okay, so you can use those on the screen, okay, from the screen.